to this video from In3D Software. Today we are going to use imos CAD/CAM iX 2019, the latest version, to create a retail point-of-sale unit. This is going to be totally bespoke from scratch, and I'm going to talk you through the steps taken to create this. So if I go to Article Designer, I can quickly create my first product by specifying the height, the width and the depth, and then assigning parts to this. I want to change my bottom to include a base height adjuster or some legs, and I want to include a back, but I'm going to use a solid back. Then what I want to do is include some shelves. So I'll choose adjustable shelf, and I will specify 3 equal gaps or 2 shelves, and I'll use this shelf that has a flush or very close to flush front to it. Next thing I want to do is add an article category. The article category will give the product its insertion height. So in this case, this is going to be an article category that inserts the product at the height of the leg, rather than a wall unit, for example, which would be higher. Once I've done that, I can save this product to use in the library. So I'll go to my project here and just create a new project, and give this a product code. So base unit open shelf, and I'll click tick. Here's my product. I can drop this down, and I have my very basic product here. My materials I can obviously change at a later date if need be, but for now I'll just have a look at this very basic product in wireframe. And if I then increase my level of detail, you'll see all of the fittings are automatically assigned based on the parts that we've chosen. I'll revert to a lower level of detail here, and I'll go back into a realistic view. The next thing I want is a product similar to this, but I want to angle these shelves. And find my angle shelf and modify it. I can then quickly choose my shelves and say that they should be the upstand type. So I'll have a piece on edge here to support my books or whatever they may be. But what I want to do is include a shelf at the very bottom. So I'll say 0 to 1. And what this has done is put 1 at the very bottom and then 3 equal gaps. And if I visualize this, we can see that the shelf is going to be brought in using the default settings to angle it. Okay, this looks good. And what I'll do now is just save this, but instead of saving over, I will save with a new name. And then click tick. I can then put this product next to it and carry on. So the next step would be to add in just my normal shelf unit again in the middle. Then I want my angle, and then I want my normal shelf. So now I have my products in here ready to go. What I need now is the reverse. So on the back side, I'll create 2 more products. So if I go to the top view, this time my width is going to be double. So I'll say this should be 1000 by 350. And I'll use the same parts as before. But this time what I want to do is have a fixed shelf. So now that I've specified my parts, I can choose a fixed shelf. And I'll use a linear division here to specify my placement. This now has one area and a defined area of 150 millimeters. Once I've done that, I will open up my lower zone and add in again another adjustable shelf. And this time I want some doors. So instead of one single door that is on set, I want double doors that are inset. This looks good. And again, I will choose my article category and then save the product. This will be called a base unit door with fixed shelf. And once I've saved that, I can then bring this product in. So I'll drop this down and I want to rotate it. So I'll select the product first and then use the AutoCAD command rotate. So now we can see we're looking at the other side because I want to move this and put this up to the back of this product. This looks better. I can then bring in my angle shelf unit again. And then I want a draw unit on this side. So again, I can come over, refresh my list, and here is my door with fixed shelf. And what I'm going to do is edit this one and save a copy with DR for draw. And then I'm going to come into my lower zone area, take off my door and my adjustable shelf, and instead I want to insert three drawers. They'll be inset to match the door, and I want these to have an underfloor guide as my system, or an in-house production drawer box. This looks good. So again, I'll just save this with those changes and I'll drop it in here. Very quickly, I've now got an island on my display products. The next thing I want is some sort of canopy or capping or worktop that's going to spread over the top of this product. So what I'll do is I'll go back into Article Designer and I'll specify my overall height. So the overall height of this wants to be 918 millimeters, which will factor in my worktop height, the overall height of my product, and the height of my plinth or kicker, in this case 80 millimeters. My width, I want this to be the overall width of the products plus the thicknesses of my side panels, which is going to be 38 millimeters each side to match my worktop. So that needs to be 2576 millimeters. And then the depth of this I'm going to have as 700 millimeters, which is twice the depth of my products. I can then add in a top, a left and a right, and this is going to cap all of my products, so my products are going to sit in here. So the first thing I'm going to do is change this top to be a top that is onset and is mitered. You can see it's automatically mitered my side panel in here, but my side panel is not thick enough, so I need to change that here to be a matching side panel type. So very quickly, I've created this sort of bridge or desk or up and over unit. And what I want to do is give this a name. So I will save it in my project folder and I'll just call this bridge. And I'll just drop this down here. If I go into a realistic view, I can then select my product and then move it using the AutoCAD move commands. So now I have an up and over style mitered worktop. And what I need now is to create some plinths in here. So if I go into my overall world, you can see down here I have my contiguous parts. So what I'll do is I'll choose this product run here, and it's brought in my default plinth. So now it's strung that across all of the units. I'll click tick, and I want to repeat that process, so I'll say this plinth should run all the way across the back as well. So very quickly I've created my island unit of some sort. Let's add a little bit more of an interest to this. So if I go into a wireframe view and then view from above, let's make a sweep to the front of this run of units here. So what I'll do is I'll use an AutoCAD polyline, which is going to run from this point here, and it's going to be an arc. And I want this arc to have a radius of 15 meters, so really big, which is going to give me a nice shallow bend. What I'll do now is select all of my edges and tell them to conform to this particular polyline that we've got in here. So next step is to select my edges, and I can do that by right clicking and saying this edge here, I also want the top edge of my bridge and this front edge, and then I want all of my front edges of my individual carcass pieces. Now what I won't be able to do is bring my angled shells in line with my polyline, because that would then bend the melamine board in the wrong direction, which is no good. So I just need to omit them from the selection. So I'm just taking a little bit of time here, just going through selecting the edges that I know are going to be required for bending. So I also have this adjustable shelf, this far one. I think I'm missing one up here for my top shelf on this particular cabinet, and then one here. So now I've created a selection. I can then say that I want to extend these to my polyline. So I'll select my polyline. Okay. So here's my polyline now. I've missed a selection here. So I'll just confirm that, that's fine. And then I'll just come back in and select the one that I missed, in this case, this edge here, and ask that to conform to my polyline, which is here. Okay. If we go into a realistic view, now we can see a very subtle bend to the front of our row of cabinets now, which gives it a little bit more interest. Now, what I want to do is bring my adjustable angled shells forward a little bit, which is possible. I can just modify my product here. And what I'll do is I'll say that this should have a divider inset of minus 20 millimeters, I think. And I'll push them forward a little bit as well, just so that they don't clash. I won't save it because I don't want to continually save over my product in case I need to use it on a different project in the future. This is just modifying this one particular change. So that's brought my shelves a little bit closer to the front. I think I can afford to maybe bring these forward a little bit further. So if I modify this again, I will come into my front section in here and say that the divider should be 30 mil. Okay, this looks better. And I'll do the same on this product here. So if I modify this article. I can say -30, and then I'll push the backs in here as well. This looks a lot better, I think. So now that we have these changes already set up, I'll leave my back edge square here because what I want is my customers to come and approach my till point or point of sale units here from this side, and this is where the person's going to stand with some storage in here that's going to be secure, and I have a little area in here. So I need to concern myself with some cable management, which is quite simple as well. So what I'll do is I'll come into a top view in wireframe, and what I want to do here is just draw a circle. So I'm just going to draw a circle with a diameter of 80 millimeters, typical cable port size, let's say, and I'm going to move that. So I'm going to select the center of this circle, and then I'm going to move it to be 120 millimeters in one direction and then 120 millimeters away from that corner. This looks a little bit too much. Let's move it back 60 millimeters. That's better. So I want some cable access for this. So what I can do now is select some parts. So what I'm going to do is select my overall top. I want the top of my cabinet and the fixed shelf below it. And with these parts, I'm going to then say I want to transfer a circle as a pocket. Now, because imos is going to link to CNC machines, this pocket is now ready to be CNC'd out, and it will line up perfectly with all of the other parts. So what I'll do is I'll come up now in my level of visualization. This will refresh the entire model, and it will add in any fittings that have cams, dowels, etc. in there. So you can see it's quite busy with all of the information. And if I go back into a realistic view, you can see I have my hole now all the way through in all of these units. Okay, now I do need to bend my plinth, so that's okay. What we can do is come into 2D wireframe view. I'll go back into my top view in here, and I will say that my polyline should be from this point here, and should be an arc to here. And what I'll do is I'll just bend this out, and I'll just eyeball this, because this will be done on site by the installation team using a flexible piece of plinth. So once I have that in position, I can then select my parts. Now, what I want to do here is select my plinth, and what I can see is that my plinths that have been inserted here have some returns on them. So I want to edit that. Now, what we have in the new version of IX is some useful features called parametrics, which allow me to come in and change the overall construction. So what I can do is say that I don't want a strip on the left here, and click tick. So now I just have one straight plinth that isn't returning, as you can see over here. And I'll do the same. So I'll change the overall construction of the plinth, and in here I can change oversizes, I can change insets, I can add in a return on the left and the right, and also on the back if need be. But I'll just remove this one here, and then click tick. That's better. What I'll do is open up my plinth here, and then say that I want this part to bend or extend the surface to the polyline that I've drawn. So I'll change that one, and you can see it's now bent my plinth and given me an offset. I'll zero that offset because I want that to come in here, and I might just give myself a 2mm tolerance. This looks better, it's not hitting anywhere along. And then I'll click tick. Okay. Let's go back into a realistic view. This is looking good. It's looking a little bit too white though. So what I'll do is I'll change some of the materials. I quite like my plinth being white and my bridge being white, but I want my carcasses to be a different material. So what I'll do is I'll go to my order related variables. These are all of the parametric settings included in imos that allow us to change certain aspects. So for example, the case. So in here, my carcass, I'll just choose this to be a nice oak. Let's see, do I have an oak preset? I do. So I'll choose a matte oak in 18mm melamine, and I will also have my carcass backs in the same. And I want my fronts to be the same as well. So in here, I'll minimize my carcass and look for my front. And instead of it being a gloss white material, let's choose an oak that is matte as well. And I can just assign this to be an oak melamine material. All of these presets can be customized and changed to your default materials. So for example, in here I also have some Ega materials, but these could be Chronospan or Polyray or whatever you currently use. I'll click apply, and this will now update my design to be using the new materials that I've specified. I won't bother updating the plinths, I'll just leave them as they are. And imos will now rebuild the product using those materials specified. That's looking a bit better. The same can be done for the handles. So if I come into here and select my two products that use handles, if I go to getting started and construction and handles, I can specify here that the handles are a totally different type. So maybe these should be some sort of recessed handle. Okay, this looks a lot better now.
So with the model complete, the next step would be to generate some outputs. One of the things that we can create with imos is some very detailed technical drawings. So here I'm in the drawing views tab, and if I choose 2D plan view, I have a series of options that I can select. And if I just window select over the model, imos will then create a 2D plan view of the 3D model. Because this is linked, any changes to the 3D model will update the technical drawing. So here's my plan view. And now I'll create an elevation view looking from the front. So here, if I choose the center and orientate my elevation marker, I now get a front view. I can also create an elevation from any direction. The next step will be to create some sectional views. So what I can do now is drop down to the elevation view and say create a section. So what I'll do is generate two sections. I can select where I'd like to create a cut and then create a section line quite simply. I'll drop this down. Now the section has created a cut through this first unit here, but I want to include everything within the actual design. So I'll refresh this view, and again I have the options to customize the view. I will add the remaining data from the 3D model and ask it to create a section along that line through the entire model. Here's the section, and we can see it's highly detailed, including edging tapes, materials, fittings, hinges and hatches for the materials. I'll create one more, this time through the draw pack. This time we also see the angled shelves that are created, as well as the draw boxes. I can use AutoCAD commands to move and position the sections. So I'll just line up my views here to make my sheet look a little neater. The next stage would be to add some sort of annotation to these. This is easily done as well. So in order to add annotation, we have the view dimension button here. Now the best way to achieve this is to load a border first. So we have a set of preloaded borders, and I'll just choose this A4 piece of paper here. And I can now position my drawing within my paper using just AutoCAD standard techniques. I need to choose a scale in order to see everything at one point in time. So here I have my three main views. I'll space these out a little bit more here. Just so that they are a bit more evenly spaced on the actual paper. And then I can specify my scale at 1 to 20. Now that the 2D technical drawings have been taken from the 3D model, imos was able to automatically dimension the individual drawings and views. We can also add in manual AutoCAD dimensions as well if need be. We can also then sheet these up
onto layouts and populate it with automatic information taken directly from the model. As you can see, the level of detail is quite high, and these can be very useful for the sign-off procedure and actual production techniques as well. So the next stage would be to create some more outputs, and what we can do here is use an imos tool called Document Manager. If I click on Document Manager, I'll be presented with a number of options, and I can choose to produce an article preview. If I click Apply here, I window select over my model. You'll see a progress bar, and as this works through, imos is creating an automatically generated view of each item that has been used to make up the point of sale counter. If I bring up my Windows Explorer, I can see here my island, and each of these items here, if I choose this one, has now had an image generated automatically of the bespoke item, which is including all the materials and specific fittings, even the custom machinings that were added in from before. This is useful because I can then create output data in the form of reports, labels, cutting lists, etc. So if I just produce an article label here, for example, I now have a packing label that can be assigned to each assembled product before it's due to be released. I can also generate other outputs as well. So I'll look at generating here, for example, a cutting list for my core material, a packing list or purchase parts list for my individual fittings, and the order head data, which has got the master information about the project. Here I have a basic cut list with all of my individual materials and parts split out. Here I have my purchase parts list with all of my fittings required to manufacture the products. Here I have my order header data, which allows me to assign information to the actual project. Document Manager is also useful for creating other types of production information. So if I go to Document Manager again, I can go to a part report and have imos create again more production drawings. This time, instead of an individual image in an isometric view, it will create an overall product drawing and the individual part drawings. All of these settings can be customized. With Document Manager now complete, I can now look at the information. Here is the image that was previously created in Document Manager. If I go back to the order folder within Documents, here is the part report that's automatically been created. And within here, I can then look at any particular product, for example, this angled shelf unit, and you'll see an overall technical drawing has been created for the individual product, as well as a part drawing.
These can be combined into a report. Here I have my overall drawing for my draw unit, and then every subsequent part has been automatically created. The next stage would be to create a 3D rendered visualization of the product. This is useful for presentation of the final design. imos here in the new version has made this simpler. We can use Create Scene. If I Windows select the products, imos automatically chooses a 3D view and adds in a ground plane with materials. I can then go to my presentation tab and choose quite a high resolution image. I can also adjust exposure if need be. Here I'll make it slightly lighter and slightly warmer, and then I can create a render. I'll pause the video here. Here you can see the render is nearly finished, and we're coming up on 3 minutes 15 seconds. This is quite a useful render for presentation purposes, so what I'll do is I'll just save this. I can now close the scene and return back to the normal view. By using the Organizer module within imos IX, I'm able to look at my individual order and run a calculation. imos is able to calculate all of the materials and hardware, as well as labour and machining times. If I open up my order, I can see all of the elements that come together to make my project and the individual cost assigned to each piece. I can then use a calculation principle and mark up certain elements and run the calculation again. Now I have my final sale price. I can go to the dashboard, and here you see that I have my rendered visualization, my customer's name, and all of the itemized elements that come together, including a final cost. If the customer is happy with my proposal, I can then move on to the next stage, manufacture. If I return back to imos IX CAD, I can then save the order, generate CNC information, and my process data transfer, which I can use for my optimization software. This may be a beam saw or a nesting solution. In this case, we'll nest this product. The first step is to use the automatic program generator. Here I have a number of different workflows for different machines and different manufacturing techniques. I'll choose a BSE nesting CNC and generate the CNC files. You can see the progress down at the bottom. Once completed, imos can also give me a report on the machining processes that have been used. Here I can see every part.
and delve deeper into the processes to identify the machining steps undertaken. Here are all of my individual CIX files ready for importing into the BSC Suite software. With the files generated from imos IX 2019, we can now import them into our WOP system, in this case B Suite. We'll use the nesting functionality to create the programs. If I import our CSV file that was generated from imos and click open, I can then click confirm. I now have the ability to process this order. Once processed, we can look at the results. Here are all of the parts that have been generated by imos, and here are the results. If we look at the oak, here are all of my curved tops and bottoms for my display units. I can then bring this into CAD within BSolid. I can optimize and then process a simulation. Here I'll speed this at a level of 20. As you can see, all of the tooling has been automatically assigned from imos. All of the tool paths, speeds and directions can be configured from imos or take the default settings from the specific WOP software. Thanks for watching.